Alright, on this video we're going to talk about a rhombus. Alright, so here in this particular video we are given a rhombus of A, B, C, D, right? Now what happens? The first thing is this: line BC is parallel to line AD, so we indicate that line BC is equals to line AD. In my mind, whenever I see a rhombus, I see the cousin of a square. I see the cousin of a square, and I'll explain. Line BC here is equal to line CD, and it is also equal to line DA and line AB. So which other shape do you know that has got all 5 sides that are equal? It's what? A square. That's why I call them these two shapes, they are cousins, right? So I've indicated with a single marking here, there, and there, that these 4 sides are equal. Now when we're done with that, now we talk about parallel line CD is being parallel to line BA. So we now have 2 markings here because this is the second pair of what? Second pair of parallel lines. Alright, now that we're done talking about that, what do we say? The only thing which makes them to be cousins is because they are not identical. On our vertices, what are vertices? Remember, you were taught this in primary. When 2 lines meet at a point here, this is called a vertex. So now I'm saying that if it was a square here, we would have 90 degrees, 90 degrees, 90 degrees, and 90 degrees, because line BA would be perpendicular to line AD. But on a rhombus, that's not the case. This here is not equal to 90 degrees, right? So that is the minute difference between a rhombus and a square. All right, but what is it that we are going to talk about really? We are now going to talk about the fact that this angle here, or we'll talk about it later on. Let's connect point A to point C rather. And here I've made a mistake. I haven't written down the features that I told you about. So let's just capture those features before I proceed with the diagonal line. So I said BC is parallel to AD, and line BC is equal to line AD. But as a matter of fact, BC is equal to AD, and it's also equal to CD. It's also equal to BA. So all these lines are equal. These 4 sides, they are equal. Then we speak about the last pair of parallel lines, which is AB is equal to, it's parallel to DC. I've already written about the fact that they are equal here on top. All right, now line AC is a diagonal line. So we say AC is a diagonal line, such that they've created what? Observe, now we've got triangle ABC and triangle ADC. But this diagonal line, what does it do? It bisects angle A and angle C, meaning to say that this angle here is equal to that angle, and this angle here is equal to that angle. This one we call A1, this is A2, this is C2, that is C1. All right. Then what is it that happens? Obviously, using your 4 conditions, what can you talk about? You can talk about the fact that line AB is equals to line DC, and line BC is equals to line DA, and then you've got this angle here. Or you can talk about the fact that line CA is a common line. So let's write those conditions. So if I'm asked to prove, they say prove that triangle ABC is congruent to triangle ADC. So I say AB is congruent to DC. So I say AB is identical to DC. Then I say BC is equal to DA. BC is equal to DA, and CA, or AC rather, is a common line. So we say AC is equals to AC, right? This is a side, that is a side, that is a side. So I've used triple S, side, side, side is my reason. And when I've proven that, now I say therefore triangle ABC is what? Congruent to triangle ADC. But please observe, this is not the only reason which I can use. I could have used angle side. Observe, angle C2 is equals to angle A1, angle A2 is equals to angle C2. So angle, and then I say line AD is equals to line CB. So there are more reasons that you could use to prove the congruency of these two triangles. All right. Moving forward, I'm going to draw a second what? I'm going to draw a second diagonal line here. So I now draw diagonal line BD there, and I tell them that BD is a diagonal line such that it bisects angle B and angle D. So this angle and that angle and this angle and that angle, right? When it is bisected, we now have triangle BCD and triangle ADC. These two triangles are equal, because if we bisected this and we showed the same coloring, it means that angle A is equals to angle C and DA. Observe, angle D, let's call it D1, D2, B1, B2. They are marked the same, meaning to say that angle A1 is equals to angle B1. No, this is not A, this is D rather, sorry, right? So they are equal. All right, so you can use any of the four conditions to prove the congruency of these triangles. Now, not only do we have that, these diagonal lines, they introduced something else. Remember, we've got parallel lines, and if I move from point B, C, A, D, if I draw it like this, B, C, A, D, and I happen to have what here? I happen to have parallel lines here, parallel lines there, right? It means that this angle is equal to that angle. So exactly B, C, A, D, and we labeled this to be A2. This is A2, and that was C1. So I'm now saying that because of the parallel lines that I have, angle A2 is equals to angle C1, alternate angles, right? So now we say angle A1, this one, is equals to angle C2, and it is equal to angle C1, and it is also equal to angle A2, and all of that is because all of that is caused due to the fact that I've got line BC and line AD that are parallel. So I say it is so because of line AD, which is parallel to line BC. So therefore all these angles that I cited are alternate angles. And then I come to angle D1 here being equal to angle B2 and angle B1 being equal to angle D2. Also it's alternate angles. If I draw from CBDA, alternate angles, because here I've got parallel lines, excuse me. So now I say angle D1 is equals to angle D2, it is equal also to angle B1 and angle B2, and my reason is because I've got alternate angles, and I have those alternate angles due to the fact that I've got AD and BC which are parallel to each other. And just like that, I've spoken about these angles. Now, not only do I have that, right? What else do I have? Remember, these two lines, these two diagonal lines, they met at a point here, which we now call the midpoint at point E. So this is E1, E2, E3, and E4. Now, what's interesting is the fact that line BD and line AC, these are perpendicular lines. So now we indicate the fact that line what? AC is perpendicular to line BD. And we know that where there are perpendicular lines, what do we have? 90 degrees is formed. So we are saying that here we've got 90 degrees, 90 degrees, 90 degrees, 90 degrees. Therefore, from angle E1 to angle E4, these are angles around a point. So now I say that angle E1 is equals to angle E2 equal to angle E3, which is equal to angle E4, which is equals to 90 degrees. And not only do we have that, now we speak about the fact that point A to point E and point C to point E here and there, these two lines are equal. So we say line AE is equals to line CE. And here we'll say 1, 2, 3, 1, 2, 3. So we've got line BE and line DE that are equal. We say BE is equal to DE, right? All right. There are other features which you find on a diagonal, on a rhombus rather. There are other features which you find, but now those are just concepts about geometry that you've learned. For instance, this triangle BAC, we can see that this is an isosceles because we say this CA1 is equals to C1, and this side is marked that these two sides are equal. So therefore, it's an isosceles, same story as there. So those are some of the things that you see, but I can't really talk about in the video. It's for you to discover if you practice geometry every day. Remember, the topic of geometry, it's a logical topic, meaning to say that it wants you to use your what? Your mind, right? That's what we mean when we say logic. It doesn't need you to use some emotions here. And this is not a topic that you prepare a few hours before the examination. Why? It needs you to prepare daily, right? Okay, with that being said, if you found this video to be very helpful to you, please do consider to subscribe if you haven't subscribed, like, share, and comment. Till we meet on the next video, have a good one.